Now that we have our note taker created for radicals, I want you to glue it onto your paper or in your notebook, and I need you to title the page All Things Radical. So this is going to have to do with everything that has to do with radicals. So if we flip open to the first one, Simplify. On this top flap here, I want you to write in that we are going to be on the lookout for the largest perfect square that the radicand is divisible by. So before we get started, let's actually go ahead and add a few definitions in here. So that is the radical symbol. And the part inside is referred to as the radicand. Okay, so now on the inside of this flap, we are going to write that we are going to look for the largest perfect square that the radicand is divisible by. And so just to refresh your memory, perfect squares are numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144, 169, and they keep going. So let's take a look at our first example here. So we need to simplify the square root of 32. Well, we know that 32 is not a perfect square. It's not in our list right here. But it is divisible by a perfect square. It's actually divisible by 16. So we can rewrite this as the square root of 16 times 2, and then we can split that up. What is the square root of 16? Well, the square root of 16 is 4, so that goes on the outside, and the square root of 2 is going to stay on the inside. Let's look at number 2. Simplify the square root of 75 times x cubed. Well, 75 is also not a perfect square, but it is divisible by 25, which is a perfect square. So I can rewrite this as 25 times 3 times, what about x squared? Or x cubed. I know that I can take out an x squared from x cubed and that that's a perfect square because x times x is x squared. But if I have an x cubed, I need to have x squared times x. We learned that x squared plus x, or times x squared times x, is where we have to add the exponents, 2 plus 1. So that still gives us our x cubed. And then we can go ahead and remove the items from inside that we know are perfect squares. The square root of 25 is 5. I don't know the square root of 3, so that's going to stay inside. The square root of x squared is x, so that's going to go on the outside. And I don't know the square root of just x. So on the inside I will have the square root of 3 and x. And that's our final answer. So I want you at this time to go to the bottom of your page, and we're going to look at a few more examples. So let's see. I'm going to write simplify and we'll make this example 3. And let's do square root of 24. Well, the largest perfect square that we know in 24 is actually only the number 4. So I can actually break this up into the square root of 4 times 6. 6 can only be broken up into 2 and 3, and 2 and 3 are both not perfect squares. So we're going to leave the 6 the way it is. The square root of 4 is 2, and then the square root of 6 stays inside. So let's try another one. What about example 4 is the square root of 72. So a little bit bigger. Maybe you can't think right away of what actually goes into 72 that is a perfect square. What can you do? Well, we can actually go ahead and just slowly start to break this down, kind of making a factor tree. So I know that 2 goes into 72. It's an even number, so I know 2 must work. So I can do the square root of 2 times the square root of 36. 2 times 36 is 72. I can break down 36 into the square root of 2 and the square root of 18. But I need to bring this square root 2 down, because 2 times 2 is 4, times 18 is 72. So I'm just building my factor tree. I can break down 18 then into the square root of 2 and the square root of 9. And then I will bring down these 2. So 2 times 2 times 2 times 9 is still 72. And then I can break it down one more time and say the square root of 9 is the square root of 3, square root of 3, and then I got to bring back down all my square root 2's. So after you do that, now what? How does this help you? Well, there's a little saying that we have that couples go out and singles stay home. So when I say couples, I'm going to circle the pairs that I have. I have 2 square root 2's. I have a pair of square root 2's. And then I have a pair of square root 3's. Well, couples go out. So on the outside of our radical symbol, I'm now going to have, I have a pair of 2's, so I'll have a 2 that goes out. And then I have a pair of 3's. I'm going to multiply those together. And they're going to go out. What I'm left with on the inside then is a 2. So married couples go out, singles stay home. So I had a pair of 2's that went out, and I had a pair of 3's that went out. I can then simplify that, and I know that 2 times 3 is 6, square root 2. So that's all we have for simplifying radicals. We will go over this a bit more tomorrow in class.